Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 9. This is Section 15.2, it's problem number 9. We want to find the integral of 2x minus 5 dx over x squared minus 5x plus 9. Now again, I can't just go ahead and solve this integral with normal methods because I have variables in the denominator that I can't put into the numerator with any type of normal means. So we need to use the substitution method. So when we use the substitution method, the first thing you have to do is choose a value for u. Now there's typically 4 choices. There's 2 that could work here. Stuff in parentheses, I do have some parentheses, so the u could be 2x minus 5. Stuff under the root, there is no root, so that doesn't fit. Stuff in the denominator, I do also have a denominator. So u could be x squared minus 5x plus 9. And the last choice is power of e. There's no e, so that's absolutely not going to fit. But in general, when you have some parentheses, a very good choice for you is the stuff in parentheses. In this case, it winds up being what's in the denominator. And if you have 2 choices, what will happen if you choose the wrong one is you'll come to a dead end, and you'll know that you should have chosen the other one. I do happen to know it's the value of u should be what's in the denominator. So u will be x squared minus 5x plus 9. Now once I choose my value for u, the next step is find du, derivative of u, which will be 2x minus 5. Again, the x squared as a derivative of 2x. This comes from the exponent of 2 coming down times the number in front, which isn't written, but it's understood to be 1. 2 times 1 is 2. X to 1 less power drops from second power to first power. The minus 5x has a derivative of minus 5 because when you have an x to the first power, the derivative is the number in front of the x, or what they would call the coefficient of the x, which in this case is minus 5. When you have a number by itself with no variable, or what they would call a constant, its derivative is 0. So that's the derivative of u, and now at the end we write dx for derivative with respect to x. And that derivative with respect to x applies not only to the negative 5 next to it, but the 2x that's out in front. So to do the job right, we really need to put the 2x minus 5 in parentheses and put the dx at the end of that to show that the dx derivative with respect to x applies to both the 2x and the negative 5 both. Now the next part of the process is rewrite the original integral in terms of the new variable. So the numerator, 2x minus 5 dx, I have a perfect match for 2x minus 5 dx. It is exactly equal to du. And the denominator, x squared minus 5x plus 9, I have a perfect match for. It's equal to u. So it boils down to solving the integral of du over u, which I prefer to write the integral of u to the minus 1 du. And as you can see from previous problems, if you try to apply the formula where we just take the exponent on our variable, put it in the denominator in front of the variable, and increase it by 1, we'll run into a problem. So if we have 1 over the previous exponent of negative 1 plus 1, u to the previous exponent of negative 1 plus 1, the denominator of negative 1 plus 1, you have a 0 in the denominator, which is the worst thing that can happen in math. So that's your flag that you can't use that technique that usually works so well with every other exponent. Negative or positive or decimal or fraction, like negative 5 would have worked fine. Negative 1 doesn't. The way to handle the exponent of negative 1 for an integral is use the natural log. So the answer will be the natural log of the absolute value of u plus some constant. And now, since the question originally was asked not in terms of u, but in terms of x, we have to put the x's back into the answer. So we're going to have natural log of absolute value of the value for u is x squared minus 5x plus 9. And there would be some constant after it.